Project code ITPW20. Project title: a 3-phase single-stage AC to DC wireless power transfer converter with power factor correction and bus voltage control. The wireless power transfer technology is recent trend. It is developing in stage. Here we are using in a power electronics concept. The wireless power transfer is very rarely used. Here wireless power transfer is used by using the coupled inductor. In the proposed concept, AC to AC converter with the wireless power transfer, and which is used for the DC application. So after transfer the power, convert into DC and used for DC application. Existing concept: conventional AC to DC converter. There is no wireless power transfer capability, and in our proposed concept the multi-level inverter is used. But in existing concept there is no multi-level inverter between the AC and DC stage. In case we using the system means for the wireless power transfer system in existing concept means we have two different stages like AC to DC and again DC to AC and the power transfer. Using the coupled inductor. So the many conversion take place in a conventional system in case used for the wireless power transfer. Existing system have the drawback of the power factor problem and the harmonics problem. In case using the existing concept in a wireless power transfer topology, and the separate stage of system conversion, I already said the AC to DC and DC to AC. This separate stage of conversion makes the system complex. The proposed concept: the single phase 3-stage AC to DC wireless power transfer resonant converter. In 3-phase AC system is first connected to the input filter. This input filter the harmonics, ripples, and given to the diode bridge rectifier, uncontrolled diode bridge rectifier. And here we using T-type multi-level inverter. It will give the DC to, here we giving the DC and the AC output as 3 level output, and using the switched capacitor in this side in other end of the T-type multi-level inverter. In case the DC output here is 100 volt means here we getting 50 volt and 50 volt. By using the separate capacitor, it will divide the input voltage given to the T-type inverter. The 3-level output is given, AC output is given to the coupled inductor. This coupled inductor acts as a wireless power transfer. In this stage the resonant circuit is used. This setup is maintain the AC voltage power factor. And again for the DC application, and again convert into AC to DC using the rectifier given to the DC load. This is the main concept of the converter. In this stage the 3-level output helps to reduce the switching losses and reduce the voltage stress of the switches used in T-type converter. In the T-type converter we use is four switches. The proposed concept used to improve the power quality, and the wireless power transfer also happened by using the coupled inductor and increase the efficiency and reduce the system complex, because here we used only 4 switches in a T-type multi-level inverter. In case in a conventional AC to DC converter, for a 3-phase uses minimum 6 switches we required without power transfer also, but with the power transfer and power quality improvement we only use the 4 switches. This is a basic block diagram. Grid is connected to diode bridge rectifier and given to the 3-phase WPT wireless power transfer with the resonant converter, and convert into DC to AC to DC and given to the DC load. Application is used for the wireless power transfer, means used for mainly for charging application in a mobile phone, for a mobile phone and the electrical vehicle, and also used for the battery charging application also. The software is implemented using the proposed concept is implemented in the software MATLAB 2015 version, and the MP lab microprocessor lab is used to develop the program for PIC microcontroller. The PIC microcontroller give the pulses, generate the pulses and given to the proposed controller. The main hardware used is, the minimum requirement of the hardware is MOSFET switches is very much important. Then the transformer for exciting the PIC microcontroller. In between regulator and diode bridge rectifier are used, and other devices like diode, driver ICs, inductor, capacitor, resistor are all used in the proposed converter hardware prototype. Thank you.